So in this lesson, we are going to talk about classifying triangles as well as some isosceles and equilateral properties of triangles. So triangles can be classified by their sides as well as their angles. So here's some names down here. This is our classifying by angles. So acute, equiangular, meaning all the angles are equal. Obtuse, you have at least one obtuse angle, and a right, where you have at least one right. By sides, we have equilateral. We have isosceles, where we have at least two that are congruent. And we have scaling, where they're all different. So those should be review for you. Now, if we're talking about some relationships of sides, so for example, this triangle ABC, we would use that symbol, the triangle symbol in front of it, and then ABC, naming all three vertex. So each point is a vertex. And this would be considered the opposite side if we were talking about angle A, opposite, and then adjacent means next to. And then if we have a right triangle, we know that we call the longest side that's across from that right angle a hypotenuse, and we call the other two sides legs. So just some vocab with triangles. Let's go ahead and classify these, and we're going to either use acute, that's a Q, angular, that's a G, it got cut off there, obtuse, or right. So these are all less than 90, so it would be acute. This one has a 90 or a right angle, so it's a right. And this one has a bigger than 90, which is obtuse, so it's an obtuse triangle. These are all equal, so equiangular. Equiangular. We kind of see that angle word in there. Angular. There we go. And then the last one, we're going to do the whole triangle PQR. And it is adding those up together greater than 90, so it's an obtuse. Now, if I said triangle QRS, that's a right. And then this one would also be a right as well, because if that's 90, then the one next to it's 90. All right, so down here, we're going to name it by its angle again. So I want you to try these three, the ABC, using this picture here, and then together we'll classify on example 3 using lengths. So try example 2, pause, and push play to check when you're ready. And hopefully you got obtuse, acute, and right. So B, D, C is this one right here, and it has a 100-degree angle, so it's obtuse. A, B, D, this little one right here, we have 20, 80, and then the other one is going to have to add up to 180, which we're going to learn, but they are all acute. And then the right is this whole triangle A, B, C, and we see that right angle right there. All right, for example 3, we're going to classify by the side lengths. So we're going to be using our vocab up here, if we can get to it, there we go, of equilateral, isosceles, or scaling. Equilateral, isosceles, or scaling. So the first one is going to be EHF. I see 2 tick marks, which means we have at least 2 congruent sides, so it is an isosceles. ISOS, so it has SOS in there, and then CELES. EHG is the whole big triangle. It has 12, 11, and then 14 when we add those up. They're all different, so it is a scaling. And the last one is going to be HFG, this one right here, which is 11, 4, and then this one would be 10. So they're all different. Again, it would be scaling. So go ahead and try this one, example 4, on your own, and here are your words written out, so for spelling if you need it. So go ahead and classify those 3 different triangles by their side lengths. Push pause, and then push play whenever you've tried it on your own. And hopefully you got isosceles, equilateral, and then scalene. So M, L, K. This triangle here, they have 2 tick marks. So that's how we got isosceles, at least 2 sides congruent. J, K, M, we have all 3, whoop, that tick mark, get off of there, but all 3 have those tick marks, equilateral. And then K, J, L, so the triangle as a whole. And we can see all these sides right there, and they're all different, so scalene. Let's take a look at it in a coordinate plane. In a coordinate plane, what we're going to do is we're going to calculate the side length. And when we calculate the side length, we can just basically use Pythagorean theorem, take this leg squared and this leg squared, and then square root to get the hypotenuse, K, the distance for KP. So it's kind of a quick way to do distance formula. So square root of my legs squared. Let me make that so it's a leg plus leg squared. So this leg 1, 2, 3, 4, 5, and this leg 1. So we take 5 squared plus 1 squared, and then we do the square root. 25 and 1 is 26. And you can just leave it if it's not going to be a pretty easily number that you can easily take the square root of. All right, on the next one, we're going to go from P to L, straight down, straight across to make that right kind of triangle. So 1, 2, 3, 4, 1, 2, 3, 4, 4 and 4, so 4 squared plus 4 squared, and we do the square root, and that's 16 plus 16, and that would be 32. And the last one, if you want to try that, go for it. And it's a 1 and a 1, 2, 3, 4, 5. So 5 squared plus 1 squared, and that is 25 plus 1, which is 26. So we look to see, do we have all 3 sides the same? No. Do we have at least 2 sides? Yes, we do. So if it's not all 3, it's an isosceles with 2. So let's take a look at isosceles a little bit closer. It has, again, 2 congruent sides called legs, and those formed angles formed by the legs are called vertex angles. And the other 2 angles are called base angles. You can prove a theorem and its converse about isosceles. So here it is labeled, leg and the base, and these 2 base angles are down here. This one's kind of tipped on its side. So the base angles would be 1 and 2 on this one, and the vertex angle would be angle 3. So kind of a lot of times we'll try and think of that vertex angle as the top, but just be careful because sometimes triangles are turned or upside down. If it's an isosceles, we know that we have 2 congruent sides, so the angles opposite those 2 congruent sides, those angles are congruent. If those angles are congruent, well, then we know that those sides opposite those angles are congruent. And that's the converse, just going the other direction. So sides and angles, and the ones opposite must be congruent. So let's name 2 unmarked congruent angles. Well, if I know, again, the side, then I know the angles that are opposite of those sides are going to be congruent. So angle A and angle C. And then if I know the angles, then the sides opposite those angles must be congruent. So that would be BC and BD. So think opposite sides, opposite angles. The other one we're going to look at is equilateral, where everything's equal. All the angles are equal, all the sides are equal. If it's an equilateral, it's an equiangular. If it's an equiangular, it's also equilateral. It's just an equa. So let's go ahead and find some missing angles here. I want to figure out what R is. Well, 5 and 5, so opposite angles must be congruent. So these must be congruent as well. And if we know this is 60, then we know that all these angles must be equal and must be 60 because it's an equiangular. So angle R equals 60 degrees. And if it's equiangular, it's equilateral, which means all the sides are 5. If these two are 5, this one must be 5, which is what it's asking for there. Down here, we're going to use our tick marks to again assist us in figuring out which angles are congruent. So again, this tick mark and this tick mark means that the angles opposite of those must be congruent. So this must also be x. And we're going to learn in our next lesson that the angles of a triangle add up to 180. So we can calculate what some missing angles are with subtraction. So 130, and then we divide it by 2, and that's going to give us 65 and 65. And if this is 65, then this one has to be supplementary, so 115. And again, these would be congruent because it's opposite my tick marks. And if this is 115, then I know 180 minus 115 leaves me with 65 degrees for both of these. Dividing that in half to figure out what each of them is, y would have to be 32.5. All right, let's take a look down here. If we know the tick marks here, we know these angles are congruent, so we can just go ahead and set those equal and solve. 2x equals 44, and divide by 2, x equals 22. Down here, if we have all 3 sides marked congruent, then we can say that all 3 angles are congruent. And if they're all congruent, then they all must be 60 degrees because we know the total in a triangle adds up to 180. And if they're all equal, 60, 60, 60, 60. So we are going to set 2x plus 32 equal to 60 and solve. 2x is equal to 28, which means x equals 14. So if all the angles are congruent, all the sides are congruent. And if we know 2, we can set those equal and solve. So go ahead and set that up and solve. Y minus 6 equals 12, add 6, and y equals 18.